Ladies and gentlemen, I've been introduced as Kaiser Moroka. When you look at your programs, you will see Ms. Fikiswa Majola supposed to be the moderator for this session, but due to some ill health, she couldn't make it. So I'm going to be in her shoes. So that is why I can just do as I wish, because I've been given this platform. Without any waste of time, I was just buying some time so that people can come in. Then I will just step down and give Prof. Pitot to come to ascend the podium to give us the mission options for an indigenously developed small satellite launch vehicle. And then we shall have those intervals as we move along. Battle up. Prof, over to you. I'll sit behind you.
Can I just take my 15 minutes?
Sure.
Okay.
In the absence of the war.
Yes. Good afternoon, everyone. I know that presenting after lunch, immediately after lunch, is never a good idea, but presenting after lunch at 2:30 is just a horrible idea. So I hope I can get through what I need to get through, but it'll probably be quite rushed. So if you have any questions afterwards, please don't hesitate to speak to myself or Mike Brooks, who's also joined us today, or our ASRI student team or engineering team. All right, so just a brief outline. Going to provide you with a quick introduction to ASRI and what we're all about. We're formerly ASREG, but we've become an institute this year, which is a great step forward for us. I'll talk about the Sapphire rocket engine. You would have seen that in the exhibition hall, I hope. And then obviously you would have seen the CLV model unveiling. I'll talk a bit more about CLV itself. Then about how it can serve the African launch market. I'll go through a bit of mission analysis, some of the details associated with the mission analyses we've conducted. And then I look at 3 different inclination categories. And the idea is to show you what CLV is capable of doing in terms of previously launched missions. And finally, have a quick look at a specific mission that's, I would imagine, of special interest to the South African Air Force. And then I'll finish off with a summary. So, and I know probably a few of you have gone through this introduction before, so please bear with me. There might be some who haven't, so I'll run through it very quickly again. But effectively, our mission as ASRI is to build the technology and the people required to give Africa, and more specifically South Africa, independent access to space. And that's our driving objective. We've got a leadership team of 4 academic staff from the discipline of mechanical engineering at UKZN. An engineering team of 4 senior engineers and 7 engineers who've effectively joined us in the past 3 or 4 months, which is a major transition for us because previously all our R&D work has been done via postgraduate projects, which is never a good idea. And then we've got currently registered 20 postgraduate students. So we've got a whole big happy family down in the lab. From a funding perspective, we've been phenomenally supported by the DSI. Just incredibly grateful for that, Kaiser. I know I have to say it every time, but I do say it sincerely every time, so thank you. And then UKZN has come on board phenomenally in the past 2 years, and they're providing us with a lot of funding support as well. Really remarkable. So in terms of our activities, 3 main activities really that ASRI is busy with: the Sapphire program, which is developing liquid rocket engines and launch vehicle technology. Then the Phoenix program, which develops small, sort of low-altitude suborbital sounding rockets. And then we have a talent pipeline program, which is all about using our tractor beam to draw in undergraduate students into our master's program. But more specifically, it's ready to expose them to aerospace engineering practice in their sort of final 2 years of university and all their undergrad degrees. And that is targeted at historically disadvantaged students. And then we do some STEM outreach. Our rate of STEM outreach is going up quite quickly now, so that's good. It's very rewarding for us as well. So the Sapphire engine itself, you would have seen most of the engine you see on the left-hand side there on display. That is an actual engine that will be hot fire tested, hopefully at the start of next year. And that is the first form of the flight weight version of the Sapphire engine. All right, so this is the engine that's being designed to provide power, propulsive power to the CLV launch vehicle. That's the hardware you see in the exhibition hall is the start of that process. So Sapphire is all about prioritizing simplicity and cost effectiveness as opposed to pure performance. So that's been our focus so far. We use very widely available low-cost propellants, liquid oxygen available at any hospital really, and jet fuel available at most airports. And we've got two technology attributes which have really helped us in speeding up the development process. The first is we use electrically driven pumps to push propellants into the combustion chamber, and we use ablative cooling to keep the engine chamber cool so it doesn't fall apart under pressure. In terms of nominal performance, the booster engine, so we have the booster engine at the first stage of the rockets, the booster stage, and then the upper stage engine for the second stage. The booster engine is nominally designed to put out about 3 tons of thrust, so that's about 2 Audi A4s, and to hold those 2 Audi A4s in the air for 160 odd seconds. So there's a lot of energy, and that's just one engine. The next slide I'm going to show is just a very short hot fire test we ran in 2021 on a Pathfinder engine we called Able to demonstrate the technologies we're now using for the Sapphire engine. So enjoy that. That was tested at the Overberg Test Range in November 2021. Okay. So that sound was really disappointing. It sounds much better in a properly played video, much better in the flesh as well. The Sapphire flight weight engine is going to put out about 50% more thrust than that. So it's going to be a really fun day out testing that. I'll just talk very quickly about the launch vehicle itself. It's a 2-stage launch vehicle. The first booster stage has 9 Sapphire engines. The second upper stage has a modified booster engine that's designed to operate in space effectively. It's about 20 meters tall, just over a meter in diameter, and it weighs about 20 tons at takeoff. And its party trick is that you can fit 3 of them in a Boeing 737 if you take the seats out. So that gives you an idea of how small it is. It's still big though, but it's small. The design payload capacity, well, the design point performance is 200 kilograms to 500 kilometers sun-synchronous orbit. It's sized really to support the majority of South Africa and Africa's future payload requirements. And it's all about minimizing the rates, the time it takes to develop, and the capital you have to invest to develop as well. And in order to do that, we have to be aligned with local industry capabilities. So all of that's gone into the conceptual design. In terms of its ability to service the African market, well, I can look backwards. I can't necessarily look forwards because I don't think anyone's really got good forecasts on where Africa's headed, but it's probably headed up and it's probably going to pick up speed as well. But looking backwards, if we look at an ASRI analysis of African satellites launched between February 98 and December 2022, we've got 49 satellites in total, 38 satellites going to low Earth orbit, and 32 going to LEO, weighing 200 kilograms or less. So that's in CLV ballpark range, without a question. So based on the parameters of each of those payloads of satellites, as well as what CLV can do, effectively, it could have launched 65% of all satellites that have been launched by Africa, and it could have launched 84% of all Africa's LEO satellites. Of course, there are a lot of CubeSats in that array there, but it does indicate that it's quite well sized, and seeing as though things are getting smaller, I think we're going to see that capacity to service the African market going up quite a bit. However, the African market's not going to provide enough volume to support this on a financially sustainable basis, at least at the beginning. So it's going to have to be a blend of African customer base and international customer base in theory. In terms of the emission analysis that we've conducted, or analyses, some details. So we considered 2 launch sites. The first launch site is homegrown. It's the Nel Overberg Test Range in the Western Cape. And for that site, we considered the inclination ranges, or range of between 40 degrees and 100 degrees. So that takes care of sort of mid-inclination and sun-synchronous orbit missions. The second site is Malindi in Kenya, which is 3 degrees south of the equator. So it's an equatorial launch site. I say hypothetical there because it doesn't have any ground launch infrastructure. It's only ever launched, it has launched several orbital rockets for Italy and the US, operating in collaboration with each other, but from sea platforms, not from the ground. But it's a very, very well-suited site, so that's why we've included it here. And the allocated inclinations are 0 to 35. There's actually a typo on the slide. It's 0 to 35 degrees. So that handles any low inclination missions that have taken place. We've used in-house ASRI codes to work out engine performance and subsystem masses, and then we've used a third-party open source tool to model the payload performance envelopes, effectively, that you'll see shortly. In terms of data source, we've predominantly sourced data from the UCS database. We've used some filtering criteria. We applied that to all of those satellites listed in the database. So apogee bounds of between 200 kilometers and 1,000 kilometers, mass range of between 50 kilograms and 250 kilograms. Data time frame of 10 years back, so we're not going too far back in history. And of course, we're not considering Starlink and OneWeb satellites. I don't think SpaceX is going to need CLV to launch any of their Starlink satellites anytime soon. So that's been excluded. So in terms of that filtration, we end up with 289 satellites, and the analysis is conducted in 3 inclination categories: low inclination, mid inclination, and then sun synchronous inclinations. So we've got groups in each of those categories. So we've got 10 degrees, sorry, 0 to 10 degrees, then we've got 25 to 35 degrees, then in mid inclination, 42 to 48 degrees, as well as 50 to 56 degrees, and then sun synchronous, 95 to 99. So those are chosen to kind of get the best kind of extraction from the data set that we could get, capture the most number of missions. And just to point out, the payload performance envelope for CLV in each of those cases is calculated at the midpoint. So for example, when we're considering the 0 degree to 10 degree range, the performance calculation is performed for 5 degrees, because we can't go and perform envelope, evaluate envelopes for each of the specific inclinations. So there's an approximation nature in the analysis in that respect. All right, so in terms of low inclination mission capabilities, obviously you can see not much is flying from the equatorial regions in the world. So this is over the past 10 years, roughly. The blue line represents in each of those plots CLV's capability, or a payload mass threshold for a given altitude. So not much happening in either of those inclination classes, but some interesting payloads going up. A very interesting optical surveillance satellite called ORS-5, and that was actually built by MIT for the US Air Force. And then NASA's been conducting some gravitational wave experiments with 2 satellites, the GCAM A and B, also completely within CLV's capability. So it's not to say that, or basically it's just to give an indication of the kind of missions that a vehicle the size of CLV can support. Moving on to the mid-inclinations, we've got a higher count of missions here in these categories. All of those missions that have been selected are within CLV's capability. The applications become a bit more interesting. So we've got the Blue Sky Earth Observation Satellite Constellation, the Capella synthetic aperture radar payloads, both in the 42 to 48 and 50 to 56 inclinations. We've got some communications satellites as well as some navigation satellites, so things are getting a bit more interesting in that respect. Then on to the sun-synchronous distribution. Just to point out here that label, or the title, should actually read 99, not 97. That's another typo. But effectively what you can see from this is the significant majority of missions in the altitude and mass categories we've looked at can be launched by CLV. Just a shout out to the South African websites, both Sunsat as well as some BandilaSat, and Dragonfly's recently launched EOSSat-1, all fit on CLV. So that's a bit of reinforcement there. Then looking at some other mission examples, we've got quite an interesting one, Athena FIDUS, which is a military comms satellite, and that's a collaboration between the French and Italian defense forces to provide their soldiers with communications. We've got some more SkySat, Earth observation constellation members, ISI, some more SAR, Earth observation satellites there, 10 to 20, all sitting kind of bunched up in one data point there. A very interesting satellite from the Korea Advanced Institute for Science and Technology. Their NextSat-1 platform, also launchable by CLV, is looking at quite a few technical development activities, so that's quite interesting. And then another very interesting one that I didn't know existed is MOST, which is a space telescope that is operated by the Canadian Space Agency. So it just shows you what you can achieve. And I think one note I want to make very quickly is that we shouldn't forget about the science, all right? We've got Earth observation on the radar. We've got a few other things on the radar, military surveillance, but let's not forget about the science opportunities that are out there with small satellites. Just having a very quick look at the Harbinger dual SRA optical surveillance satellite mission. Quite interesting satellite. So it does its Earth observation or surveillance in both obviously radar wavelengths as well as visual wavelengths. And that was basically a bit of an experiment run by the US Air Force to take a commercial system and basically see how well it meets the Department of Defense, not the Air Force, how it meets their requirements. And I think it's doing quite well in its missions. So that was launched in 2019 by Rocket Lab Electron from the Mahia Peninsula in New Zealand. It carries an ICE X3 SAR module, and then well within CLV's capabilities, 150 kilograms to around a 500 kilometer orbit at about 40 degrees inclination. So again, very hard-hitting hardware that can fly on small launch vehicles. So in summary, I hope I've been going fast enough, Kaiser, but I'll wrap through it quite quickly. So in our view, and we've been at this for a while, probably more than anywhere else in the country, and that's not to say that we know everything and we're getting it right, but in our view, what CLV is the optimal means of Africa and South Africa getting sovereign access to space. It matches almost all of our needs, our requirements, and it's the correct technology architecture to be using for cost minimization as well. So just looking at its capacity, it could have launched the majority of Africa's past satellite missions, and the vast majority of international small sat missions that fit in those two categories, 50 kgs to 250 kilograms and 200 kilometers to 1,000 kilometers. So it's a very versatile payload capacity, let's put it that way. So we, as the Institute now, are moving full steam ahead on getting Sapphire developed and putting in the building blocks, or putting building blocks for CLV in place. So that's things like flight termination software, propellant tanks, all sorts of other little bits and pieces that need to start coming together. Just a few milestones on the horizon that we're targeting. First quarter of next year, we should be testing the first ground test version of the booster engine, booster Sapphire engine. Then hopefully mid-year next year, just before mid-year or mid-year itself, we'll be commissioning a commercial sounding rocket gantry down at Oberg Test Range, and that is going to be able to launch a significant number of international sounding rockets from NASA and ESA and other sources as well. So that's really exciting. And then hot fire testing of the first full configuration flight weight engine towards the end of next year is the target. And then finally, we are hoping to launch around mid-2025 the Steve sounding rocket, which is, Steve stands for Suborbital Test Vehicle. It's basically a flying platform to test Sapphire engines in flight. And the exciting thing is it's also space capable. So when I say that, I mean up and down space capable. So we will, according to the forecast at the moment, pass 100 kilometers if everything works okay. And that'll be the first instance, I guess, Kaiser, since the previous military program that South Africa puts things in space. So that's really exciting. So again, thank you to DSI, phenomenal support from them, as well as UKZN. We are indebted. If you want to find out more, website there, my email address is there, feel free to contact me. And if I could be a little bit cheeky, the Institute is in desperate need of a good electronic engineer. All right, so if anyone knows of a good electronic engineer who might be interested, please let them know and get them to contact us if they are. Other than that, thank you very much.
Thank you, Prof. You did it in 15 minutes. So the next one will also do 15 minutes, I guess. But I'm told that there's something after 4. That is why I'm rushing you. But the information is too good to be shared. We can't cut it off. This morning, in this session prior to this one of the speakers said he loves fire. So he's a creator of fire. Next year you can come and witness that fire at OTR. I think it was Dr. Kanyaho. So you will tell me whether is it that kind of fire that you like or not. Ladies and gentlemen, indeed, this morning we witnessed the unveiling of the model that is built by the university, UKZN. Our next speaker, and thanks, Prof, for the presentation. It was quite good. Development and deployment of low Earth orbit nanosatellites for maritime application. The next speaker is Mr. Nyameko Hoi from Cape Peninsula University of Technology. It's replacing Sina. I don't know whether he'll present the same topic or he's coming different. But the topic here is development. Thank you. Hoi. Yes. Can you give him a round of applause?
Good afternoon, ladies and gentlemen. My name is Nyameko Hoi. I'm from the Cape Peninsula University of Technology. I'm currently standing in for Sinamandla Maqina. He was supposed to do the initial topic, but unfortunately, he had some personal issues that he had to take care of within, I think, sometime by the end of last week. So I had to just stand in for him as from yesterday. So my presentation basically is kind of a lot of what you've seen previously because I was not really prepared. But I will try to keep up and try to keep to the time because I see that maybe somebody else has joined for Mr. Khalakadi, so I'll probably be back to 7 minutes, which is a good thing for me because I am not highly prepared. Well, basically, to just give you some background of CPUT, we started our program, I think, around 2009, 2010, when we had a bunch of master's students. We were like first-year masters. And then we tried to, actually the main project was to develop a small satellite. So we had to just build our thesis with themed around building a small satellite. And the nice thing about building small satellites is the quick turnaround time, whereby actually once you have an experienced team, you can basically build it within 6 months. But with the students, then it took us 2 years to build it, and then within that same period of time, actually, we actually managed to watch the satellite getting launched. Most of the times, like when you have this student-based program, it's you will be writing your thesis, and then you'll be done, you'll be industry, and then the satellite will be launched like after 5 years. So with the CubeSat missions, it was the nice thing that you can be part of that program. Okay, yeah. So basically, was the student project that was launched in 2013, which was mainly built by about 8 master's students. And then you can see we still have actually the video of the rocket launch of that. It was quite exciting for us and for South Africa as well. Just to recap as well on the I think the slide actually, it also feeds into the loss of Dr. McKinley from SANSA, because she was one of the people who were helping us build the payload for that satellite. The main payload basically was just an HF beacon that we utilized to characterize antennas in the Sinai region of the Antarctica. And then they utilized SANSA HMO, the one with the very fancy facilities. Actually, we saw them about 2 months ago. They were really nice. So they utilized those antennas in the Antarctica to observe the space weather, which is like your sun-generated space weather, not the normal climate. So we developed the satellite, and then we launched it in 2013. As well, in the satellite, we kind of included, goodness. Okay. Yeah, within the satellite, we had an imager, a small imager, that we utilized to basically, the entire satellite concept was to train students. We don't, it's not basically to produce so much science or so much value, whereas it's to train students, to train people how to. That's the main thing with our training center. But within that time frame, I think at the beginning of Oceans, actually it started with the NDP 2030, that was released, I think, 2011 to 2013. That was published by government. And then within that, there was a proposal to do, there is a section whereby we had to work with Operation Pakistan. Operation Pakistan was a government strategy that was utilized to basically extract as much or utilize as much of our ocean resources, because currently the government felt that we are not utilizing that as much as we can. So from there on, we proposed, we did some sort of a research-based. If you come actually to our stand, you will see some of the previous slides and the retentions of these satellites. This was the final satellite that we had, but there were some models that we kind of proposed to carry certain payloads in order for us to track vessels in the marine oceans. And then as well as within that proposal, due to the space that we had, and then we envisioned then, we sort of, with the CSIR, we engaged with, I think it was Prof. Derek. Okay, let me just use Derek, yes. He was an optics guy from CSIR, and then he proposed that if we have much space in there, he was also doing some research on the K-line sensor that he wanted to develop, which was a camera that he tried to develop to detect fires. So the entire satellite, it was quite a successful demonstration that we implemented. That was launched in 2018. Basically, you can see from both payloads, we built this SDR together with Stone3. Stone3 had these big radios that we utilized for terrestrial demonstration, and then we took 2 of our students, if I remember correctly, Stephen and Motlokwe. They developed the interfaces and some of the front end of that SDR. but the application, it was still based on Stone 3. That's why the collaboration was called between Stone 3 and CPUT. And then that is basically the ships that we tracked actually within seconds when we turned on that radio. And then as well as you can see the Brede River, I think somewhere here. Okay, the picture is, okay, you can, other way around. Yeah, so you can see that that was the images that we received from the same satellite, which was Tube 2. It was launched in 2013. So fast forward from that data that we received from the successful operation and the demonstration of Tube 2, we proposed to engage the DSI as well as CPUT to put together a constellation of satellite, which was the first constellation basically that was launched in Africa actually. So we launched that last year in January, 13th January, actually the date is there. Yes, and then we launched the satellites in 13th January, but we kind of changed actually the SDR. We included some few functionalities on top of that, which was like we wanted to do some over-the-air upgrades, as well as we wanted to capture raw data, which is with raw data, basically we can analyze our shortfalls, because we could see like sometimes with the AIS radios, if you have too many transmission at a certain section, you might not be able to detect everything that is in there. So we wanted to also work on that and improve the efficiency of messaging and messaging schemes. Okay, that was actually just a 10-second capture of that launch early last year. Yeah. That is always an exciting moment for us, fortunately. And then the most important part of after that launch, of course, there was always some issues that were kind of opposing actually the actual development. Actually, there were some problems that we encountered basically. Okay, so with the two satellites, we couldn't actually operate the main payload, which is a kind of a failure. From the engineering perspective, it's kind of an egg on my face, or very embarrassing moment. I promised myself that I was not going to talk about that today, but unfortunately I have to say something about that. But the satellites in generally, to showcase actually the technology that we produce in South Africa, the radios that we have, we implemented in that mission. They are currently operating. If you look at this, these are the messages that are received from Slack, from the current satellites. If you look at the date, that was today at 8:10, but that's UTC, all right, at the time there. So these are the messages that we got today. It's mainly telemetry and the actual status of the satellite, but it's still exciting that those satellites are still functioning. We can still track them within our ground station. Okay, let me skip that now. Okay, currently we're working on a following mission, which is the machine-to-machine. Basically, it's still the same type of, like when you develop something, the engineering way of developing, you build once, and then once you find a little bit of success, and then you follow up to the next stage, and then you kind of grow from there. So with the machine-to-machine, both of those missions, the MDA mission and as well as the Zytube 2 mission, we mainly have receivers on board the satellites. So now currently, we're including a transmitting part in it, which has some terrestrial functionality into it, but I can't really delve into that. Basically, where we are now currently with this, you can see that we've developed an engineering model. We had two interns actually working on this, assembling this engineering model, as well as our EQM, but unfortunately we assemble it and then we find something wrong and then we dismantle it again until we get it right. But that's just part of the job, right? So yeah, basically this is where we've been now. We've currently already deployed actually the flight software, but there's still a lot of bits and tweaks. And then more especially the concerning part, as I've told you, that we've failed a little bit from the previous mission. So the main concerning part is the payload. So now we're focusing on that payload, the development of the software that goes to that payload. We need to make sure that it works to the T. Of course, we've developed over the years a lot of radios. I mean, these are the antennas, X-band antenna and the S-band antenna. And then there's the radios that we've developed. Actually, I think there's more missions that have been flying on. If I can just, I think there's over 100 missions actually that these radios have been utilized, including our missions. These are very sought after radios. Basically now, currently, these are our research facilities. It saddens me that we only took pictures of the very nice and clean test station, and then we have equipment there. But yeah, as I've said, that we are currently rebuilding due to certain unforeseen, we can't directly compete with the private industry. So now we have to train, basically, do what happened in 2009, get a bunch of students, train them over the years, and finally get some results, and then possibly it's something that is going to be good for the industry and as well as good for the economy of South Africa. Yeah, this is the ground station that we currently utilize. It's an S-band ground station. This is our FM area. This is the clean room, actually. It's not the FM area. That is in our facilities. We need to see much more action, actually, in those facilities. This is the MTA set that we tested, and then we've got a general lab and a classroom that can handle over 20 students. Currently, next year, we'll be receiving about 20 students from Africa that are going to be doing training there. We were going to do this systems and mission analysis design, a SMART course. I will be giving them, that will be just a week's course, but it's not a full course, but it will be just a crash course. So that just shows that we still have the facilities, and then we're still trying to embark on getting more students involved within our program. Yeah, and I would like to thank the DSI and CPUT, SANSA, I mean, all of those people, companies that are listed there, and government agencies, they supported us over the years. Thank you.
Thank you. Thank you, Mr. Hoy. This morning we were reminded of an idea. The speaker said, if we have an idea, you must explore it. But if you are afraid of failure, then don't do anything. Then you won't fail. So let's fail forward, CPUT. Keep the good work going. It's a good thing that you participated and contributed something to the Operation Pakisa, ocean economy. Though you failed, we're also doing the fire detector, K-line research. Where is our Mr. Kanyaho again? He likes fires. Here are the people who makes fire, who can detect fire for you. You can detect fire together. Ladies and gentlemen, we will move to our next speaker. I'm sure those questions are rolling in. Our third speaker will be Dr. Rendani, geomagnetic jacks observed in geomagnetic observatory data over Southern Africa between 2018 and 2022. Can you squeeze the 4 years into 10 minutes, ma'am? 4 years. Thank you. Over to you.
Thank you. But I'm here to talk about space weather. So you have heard about the fantastic or the awesome state-of-the-art Regional Space Weather Center, like she used to call it. So we are inviting you to come and have a look at our Space Weather Center, and I will tell you more about space weather now. So we're looking at space weather and understanding the societal and economic impact. So some of you will ask yourself a question, but what does space weather has to do with society and our economy? Actually, it has everything to do with it. Mostly because of the interdependencies, your technologies, the fourth industrial revolution, the ever-evolving electronics, and the electronic becomes smaller and smaller, so they become vulnerable to space weather. So you're asking yourself, what is space weather? So basically, you look at the sun. This is our laboratory. So you look at the space between the sun and the earth, and whatever activities that are happening on the sun, how does that affect your technology on the ground and then the spaceborne? So which means from your satellite, your ground-based receiver, anything that utilize satellite or GPS, your GNSS, high-frequency communication, you can name all of them. So they do get affected by space weather. And everything stems from the sun. So you've got period where you've got the the sun has 11-year cycle. So you've got a period where it is quiet and it is spotless, which means you will not be able to see those activities like your solar flare. Solar flare is just a flash of light that gets emitted from the sun, and it takes about 8 minutes to reach the earth. So you only have time for a warning. And then you've got coronal mass ejection, which is a cloud of plasma that get propagated from the sun. That at least you get about 1 to 3 days to monitor how the event is evolving, and then you can actually get a lead time to say, this is what is happening. These are the different systems that can be affected so that people can be prepared. So we provide the right information to the right people so you can make decisions. We're not going to tell you to say stop operating. We're going to equip you with the information so you can make the right decision. So this is picture just show you the, kind of give you an idea of how interconnected between all the system from the sun to the type of event that happened, and what is the impact on the earth, and the effect that stem from the sun, what is affected, and the different systems that can be affected. So you can actually see there, you have got your railway electrical circuits, your power grid, loss to GNSS and GPS, GNSS correction, loss of log. You can have impact across the board, like I said. So, and if you're sitting there, you're asking yourself, how many of these systems that you use or the technology that is most dependent on the GNSS or GPS receivers? So it ranges from, I'll show you now on the next slide. So this one is just showing some of the source of the space weather, the solar flare that I talked about. This actually affects the atmosphere. So you communicate, right? So when you're using your HF, high frequency communication, or very high VHF, or whatever, any kind of communication, even the signals from the GNSS and the GPS, they have to utilize the upper layer of the atmosphere, which is the ionosphere. If space weather happens, that layer it changes the characteristics. So you got a lot of ionization that can actually affect your signal. You can either send the signal and then you get total absorption, depending on the type of event that is happening. Or you can have a partial absorption. So, and the impact, you can see, you can have HF communication problems. So how many people use this or depend on the usage of the high frequency communication, like I know the Air Force, SNDF, SANDF, and also emergency service, police. So, which means it ties in terms of your security. So it does have impact in terms of how you operate your system. And then with the coronal mass ejection, that is the cloud that I was talking about. So you have what we call geomagnetic storm. So, and what has been found with that one, you actually have more impact in terms of the power grid. Because if you have an accumulative of this storm following one another, then it can actually generate the geomagnetic induced current. So those artificial currents can accumulate into your transformers, and then at some point it can cause problem. So, and also that can also accumulate into your pipelines and into your railways. So we need to understand the impact, and then we can actually mitigate. And then also when flying or when launching your satellite or your CubeSat, you need to avoid, or you cannot launch during space weather event. I think we have a typical example of the satellite, the Starlink satellite. They lost about 32. What happened is because they launched during a space weather event, and their satellite experienced what we call satellite drag. So because of the increase in terms of the energetic particles that were concentrated there, then they couldn't reach the altitude to launch the satellite. So that is one of the things that can happen during space weather event. So which means if you are a satellite operator, you are an HF operator, GNSS operator, so which means if you have this information, we can actually tell you there is a space weather event happening. So it will be up to you to say, okay, do we go on with the launch, or can we wait until the event subsides, and then we can continue with our operation? This picture here just give you an example, or just show you some of the different systems. You can see there you've got electric grid disruption, telecommunication, your ground receiver, the radio wave disturbance, your satellite, your navigation system, in-flight, or whether you are doing shipping, maritime, your freight, your banking. You know that for financial sectors, you actually depend on the timing. That timing of the clock is very crucial. Or imagine you are doing a transaction of billion, and then you just miss it by that one. You send it to a wrong account, or you are transporting your precious cargo, but then all of a sudden you experience a problem with the GNSS. You can't track where your goods are. So what happened in that, whether it's a 5 minutes window or a 10 minutes window or an hour window, what happened to your goods or your services, for example? So we need to be recognize that it's critical that we understand the impact of space weather on our society. And also because this does not only affect, it actually affects the global chain, supply chain. Because if then you cannot do trade, for example, if you are doing stock market, you cannot trade, you cannot buy, you cannot sell. What is the impact for that time, for that day? If you cannot track your goods that you are transporting, whether by train, by ship, so you actually have to look into that and say, okay, but should we know about space weather, we could have waited and say, okay, don't do it today or within these hours, just postpone it by an hour or 2 hours, and then we can see what happened then. And there's a lot of talk about the fourth industrial revolution. Space weather also will have an impact on that. So if we actually understand and we are able to mitigate, the good thing is, like I said, we've got the state-of-the-art regional warning center, and the only regional center in the globe, actually, amongst the 4 global centers. And we are the one that is recognized by the International Civil Aviation Authority to provide space weather information to the aviation industry. So these are the different sectors, like I've been highlighting. These are the different sectors that can be affected by space weather. Your impact will be, are you a GNSS GPS user or are you a HF communication user? So either way you get affected. So, and then if you are saying economic, what will be the impact if you have to, for example, to ground or to close an airport for 30 minutes or for an hour? So which means if there are people who have to be rebooked to the flights, who have to incur the cost. If you have to pay additional man-hour for the pilots, for the crew members, if you have to actually, instead of taking the shortest route, you have to go around because of the space weather event, there is an increase in terms of ionizing radiation, then instead of doing, let's say for example, you are doing a polar route, now you have to go around, so which means you need additional fuel that you didn't actually budget for. Where does that come from? Actually, even parking at the bay, you need to pay for that. Because then it's unscheduled, then it's an extra cost. So that's why I'm saying economic impact. And then also your maritime, your navigation, the accuracy, position to determine where exactly is the location of your ships and your vessel trafficking, marine communication. So if you look at this, you can actually see that almost every division or every sector is affected somehow by space weather. It might be at a different level, and then on depending on the type of the technology that you use. So this is the interdependence that I was talking about. So for example, if you lose power for 2 weeks, so where you actually cannot even get your, let's say you exhaust all the resources in terms of your backup and all of that, what will be the impact in terms of your health, your water supply, the emergency service and all of that? So the vulnerability becomes now on the interdependencies of the different systems. Okay, so this is just, I'm just gonna rush through it now. Some of the example of space weather events, you can see there, this is example for where you cannot use your HF communication because there you can see you have a total blackout. And which means your aviators, your marina, the HF users, then they were not able to use that particular frequencies that they use for that particular time because of the space weather event. And if you look here, I was talking about the systems that depend on your GPS, your GNSS. All these are the different industries or the sectors that depend on the usage of the GPS and the GNSS. And if you have loss of log or error range, because then space weather event is happening, you get affected one way or the other. So what does the monetary value look like? So if you're talking about the extreme space weather event, which has not happened yet, you're talking in terms of trillions. If you're talking about moderate, it will be in the millions. But then you actually have to compare to, as a developing country or as Africa, compared to the rest of the world, what will be the value that, considering our infrastructure, considering our GDP and everything else. So what will that number look like in terms of if we get impacted because of space weather? So I think it would be better if you understand and then we can mitigate. And then we can actually minimize in terms of the cost and the loss. So the good thing is we have the solution. We've got, like I said, we've got a 24/7 space weather center. Thank you to DSI for supporting us. So we established the center. And currently we've got the 8th space weather forecaster, the very first in Africa and in the whole world, if I can say that, because there's no university that offers space weather as a course at the university level. And I'm proud to say that out of the 8, we've got 7 ladies and 1 gentleman. So yes, we are very proud of that. How then do we actually come to say we can actually provide you with the information so you know better, so you can make the right decisions? So we're actually not going to tell you that stop operating, don't fly your flight, or don't transport your cargo, but we'll equip you with the information to say, this is what is happening, so you'll have to make that decision, knowing that you actually have the information. And we can actually do training for the industry in terms of that you understand what is the overall implication, what does it imply to your industry in the operation level, and how can we actually design or develop the product and services that are tailor-made to each and every industry. I think, I'm almost done. So like I've mentioned that space weather events create vulnerability within our technology dependencies, and it's also a risk to 4IR or 5IR if like some people have it. And we've got a state-of-the-art 24/7 operational center, which you are more actually welcome to come and see, and also bring your people interested in training and everything. Then we can talk a lot more about that and give you the different options that are available. And like I've said, almost all the sectors get affected, but it might be different at different levels, and also depending on the type of technology that you are using. And we actually looking forward to working with all the different sectors in terms of mitigating the risk, and also doing the training and knowledge sharing, because then we are actually supporting the knowledge economy. So we actually have to work with it. And also we are so big in human capacity development. Thank you.
Thank you. Thank you, Rendani, from the only regional space weather in Africa out of 4 in the world, for providing us a solution how to mitigate against the space weather, solar flares and stuff like that. Thank you. I'm sure they will engage you further tomorrow when they see you around. Tomorrow, the CEO of SANSA will give a talk at 9 o'clock. Remember, he was, unfortunately. So tomorrow, 9 o'clock, Mr. Umbulane Mudau will give a talk, 9 o'clock sharp. Our next speaker, ladies and gentlemen, we're really working against time, but this is a good information to share. Mr. Christo, you are next with an affordable test platform. Can you take us through an affordable test platform? Give him a round of applause. Welcome. Thank you.
Thank you. Thank you, Mr. Kaiser. Thank you, ladies and gentlemen, for listening to me in the graveyard shift. And I just need to say that space weather is real. You can ask the Canadians and the Americans. They experienced some grid failures because of that. And yeah, the prof made me think. He spoke about the tractor beam. And then at some start date, Mr. Spock, the Enterprise, had problems with their toilets. So Mr. Spock came to Captain Kirk and asked, what do we do? He says, Mr. Spock, just don't go where everybody else has gone. So yeah, we are the BACAR team. It stands for Balloon Carrying Amateur Radio. And we started out in 2013. Our last slide, I will elaborate a little bit about that. But if you also wonder where do we fit in the 0 to 50 kilometers range. You guys play much higher than us. And we do have a vision. We have a vision about learning. We have a vision about science. We like theory, and we love teamwork. And therefore, my chief engineer, Willie, is here with me today. The chief or the master chaser, Gert, is not here. He's at home attending to some business there. And we also have a chief operations manager who manages the day of the launch from his ground station. That we also have UHF, VHF, S-band, and several other band capabilities in our ground station. But if you look at all 4 of those areas, the one thing that I think ties them all together is collaboration, and then the youth. The youth is the people that we really like to work with, because we open their minds, they get excited, and some of the people that has attended our program in 2014 and 15 is now junior engineers, also working at my working place. If we look, we also have a mission, and the last sentence there is, we turn unsuccessful into successful and never give up. Now that is the easiest thing to do, is to give up, especially in the realm that you guys are playing and where us are playing. It's not easy to put something in the near space. Our motto is Caelum Prope Spatium, it is the space close to us. So it's not easy to put stuff there, it's not easy to get something and a payload up to 30 kilometers, it's even worse for you, but that's where we will fit in and help you to test your stuff before you send it into real space, and also for prototyping. What I want to show you is a few pictures. This is where the size of our balloon. It's a 2,000 grams balloon, and sometimes we do fly 3,000 gram balloon. It just depends on the payloads we are and the mass of the payloads. It's usually about 12 kilograms that we launch, between 8 and, well, the most payloads is about 10 that we have launched. And if you can see there, look at the children's faces, excited. That particular school come from Kroonstad in the Free State. They drove 250 kilometers from about 2 o'clock in the morning to arrive at the launch site at 5, so that we can launch 2 hours late because of the winds. But that is what happens. All right, since this is an Earth observation conference, there's a few photographs of Earth observations that we took while we are flying. And the one at your bottom right corner, that is Chrissy's Mere area, where the Vaal River starts. So you can see the topography there. And the bottom left, you can see a veld fire also burning. And then that is the bottom right again. That is the photograph we all hunt for when we do our balloon launch, because that proves that we were in the near space. There was no water to deflect the sunlight, to give us any blue in our picture. It is a black picture. It shows us that we were out of the breathable atmosphere, and we were in the near space. Every time we fly the balloon, there's about 8,000 photographs being taken by the different payloads. So everybody is looking for this particular photograph, because we also want to be the best, because there's a little competition between people and putting it on the balloon. There is some pictures of our payloads. Yes, it is not as sophisticated, but it also doesn't cost R1 million. But what we need to understand is that some of those payloads are built by people that comes from the shacks and the previously disadvantaged areas. And the schools in there doesn't even have a Proxima. So it is the innovation that we get from people that is not being exposed to certain types of technology just makes the innovation on their part much better. And you can ask Willie on the innovations that we have seen from people that has not been coached or coerced in certain directions, because they have free minds, so they can do everything they want to do. I think on the top right there is our video payload. There's a few Raspberry Pis in it with the cameras. It's also 3D printed, the space frame, as we would like to call it. And the polystyrene you see around it doesn't really, what we've seen in the past 10 years, doesn't really do anything about the protection against the cold at the heights to the electronics on the inside, it's very porous. And because you are losing air pressure, everything inside just gets sucked out of your balloon sack. But it does help when our parachute doesn't deploy. It acts as a shock absorber. The one day, yeah, stuff happens. Okay, yeah, and normally our payloads, there's power supplies, microcomputers, sensors, other experiments, and then always an RF package, because on some of the payloads you want to have real-time information on the ground. That gives us also the ability to track these balloon sats, as we would like to call them, and see the condition of the balloon sats, the battery conditions. Because the one time we have given 5 different teams 5 different types of batteries. So they had to go and choose and bid for it. It was part of the training exercise, so they have to choose and bid, and then get some of the batteries stopped working at about 10,000 meters because of the cold. They didn't read it in the pre-work that we have given them. But yeah, and then as I said, the maximum load that we want to have is, the mass is 500 grams, 10 by 10, because we want to get them all used to CubeSats. We want to get them to use to the form factor. And how do you get stuff in there? So our next step will be pico satellites, 5 centimeters, so that they also get used to that form factor, because it becomes more and more affordable for people to make their own little satellites and send them up, test them a little bit. Yeah, and with the insulation is about 14 centimeters. Very important is the construction. We do not want to lose our payloads. So we are giving them also the ways and means how to make the best knots. And we have developed a system where your payload does not have to take the strain of all the payloads below you. Because we don't want your space frame to crack and break, and then we lose 10 or 8 or 5 bottom payloads somewhere in the felt that we don't know. So we would like to keep everything together. Therefore, as you can see on this drawing here, it's a loose line that runs through your payload. That takes away all stresses and strains on your space frame. And it helps a lot. We have not lost any payloads yet. And 12.5 kilograms that hangs on those lines. And they get, there's about 5-6 Gs of what do you call it, stress on them. Now, if we are putting a lot of payloads, there is 10 payloads in there, most of them have some sort of an RF package in it. We need to decide where it must fit. So we do a little bit of frequency coordination, power coordination, also ask the guys to stay within the radio amateur transmission bands, so that we don't get problems with ICASA. And also, there's 5 trackers on our standard payload. We have a spot tracker, which is a search and rescue type thing, for a satellite tracker. Then we have APRS tracker, we have a normal cell phone tracker. We have also a LoRa tracker, and on the last flight there was somebody with a LoRa WAN tracker also. And on this in this October on our flight we will have about 2 or 3 cross-band repeaters on FM. One will be on sideband as well. But on the FM side, previously in 2018, we did make a contact between Pietermaritzburg and Lichtenburg using handheld radios, which shows you what line of sight can do and what is the height going to do for you when you are playing with radios. Also, this is a dangerous story. People can get hooked on, they can stand on the lines, and then we will lose the payloads. Because if the balloon goes, you can watch the video, that thing goes up at some speed, and then you will lose half of your payload. It happened once, I witnessed it, and since then we've instituted certain areas for people to go and stand, and children must be on their father's hands. They cannot run around there because one day one of the children stood on 2 of the payloads, and then the balloon left, everybody's staff stayed behind. It is just excruciating to see those people's faces. All right, so we try to be a little bit formal as well, and we have a whole program worked out there. We arrive, we brief, and we prepare our payloads. We check everything and make sure everything works. Then we launch it. Once it is launched, it is obviously everybody scatters and runs because where is it going to land? And we use some software on the internet to do our flight prediction. There used to be about 3 sites that we could cross-reference and make sure we get the area where this balloon is going to land. Lately, there's only this one that is running. I think this is the CUSF site. And we have now tuned the weight of the payload, the size of the balloon, the meter readings on our regulators to put the hydrogen into the balloon to sort of perfect where this balloon is going to land. And it happened last year that the chase team was waiting and they could see the balloon. They could see it disappear when it burst, and then they could again see when the parachute opened and it landed 800 meters from them. It was I got, goose bumps just to hear them on the radio. It says, we can see it. It was just exciting to experience that, and to finally, after 10 years, you can now predict more reliably where the balloon is going to be. And this is my last slide that I want to stop with. I have to make time for our other speaker. The altitudes you can see there, you can see the teams that is participating. The bottom one there, the 2013, we were one team. That was our first launch. Some people in the CIA lost control of their bowels one day because we flew over Johannesburg approach. So it was not a very good day for us and for them. But it's past and they forget it, and most of them is not working there anymore. And our new application for the flight is in, so I'm eagerly awaiting approval for the 14th of October. And then if you can see there, the teams, there's always about between 8 and 10 people in a team. And if you count it up, we have touched 300 people's lives with this program of ours. And if you can think of it, that they start with nothing, they can't even solder, and then we help them to solder. So there's also more advanced guys that has flown with us, like the University of Witwatersrand. One of their master students built a ion engine. I just call it a warp drive. I can associate with that. And he is again flying this year. From the lessons that he learned with us, he have improved the engine, and he wants us now to switch it on and off for him remotely. We are working on that. But if you want to know more, the time is a bit limited today. Just come to the stalletjie there. Don't walk past it and think, where do these guys come from? We misread some of the smaller print in our brief. So, but anyway, please come and make a visit, even if it's just to have a chat. Thank you for your time, and I hope you've enjoyed it.
Thank you, Christo. We indeed enjoy it, but I encourage you to collaborate. UP, Christo, UKZN, play around with these toys. In the process, enticing young ones to follow career in science, particularly space, science and technology. Ladies and gentlemen, there's a request from the floor, from people above me, that I should request the last speaker to do his presentation tomorrow, because we've got youth waiting, they want to go home. If you look at our program, we're supposed to have a youth session at 3 to 4. Now it's 4:30 already. So can we give them that 20 minutes to do their session so that we can release the Chief of the Air Force. Ladies and gentlemen, now the questions, that is going to be tricky now, whether I will entertain questions. But we received talks from UKZN, Sansa, and Baka, Christo. Quite interesting talks. They reminded us of the impact that space weather is impacting on us on a daily basis. The UKZN was taking us through the inclination capabilities. We appreciate that. CPUT giving us their background since 2009. We really appreciate that. Can you give them a round of applause for appreciation? The last speaker was supposed to be from SANSA, Mr. Justin Whitten, but unfortunately, Mr. Whitten, I have to reschedule you for tomorrow together with your CEO. I don't know whether you'll speak after him or before him. My chairperson, I think I tried to do justice to this. So what do we do with questions? I'm not too sure. Should I read the questions or we stop here? And, okay, the instruction is stop here. Okay, I'll stop here. I'll share questions with you tomorrow, one way or the other. Round of applause again. That brings to the conclusion of my session then. With pleasure. I thank you. I thank you. Thank you.
Thank you so much, Mr. Kaiser. We really appreciate the session, your moderation, and thank you to all the speakers and our sincere apology to Mr. Justin, who will make up tomorrow. I would like now to introduce the youth session, which is the Earth Observation Monitoring Demonstration activity, will be led by Mr. David Tabane of Arrows Technologies and Solelo of Abiri Innovations, together with their team from Arrows Mission Control Citizens, scientist coordinators. These are the young professionals from the various areas: Bethany Village in South Africa, Modikwe Village in South Africa, Makolokwe Village in South Africa, and Kopong Village in Botswana. At the same time, we have, young people, they are very technologically inclined, so we have those who will be joining online from Lerotodi High School learners. Mr. David, would you please step forward with your team as our guest speakers decline? Thank you so much. Can we please appreciate our guest speakers? Thank you so much.
Thank you. Thank you, Chair.
And to the youth, the now and tomorrow leaders, thank you, Mr. David.
Okay, thank you everyone for being patient, and our program leaders. We managed to just get a few children to stay behind. Most of them have gone because they were expecting to be online at 3 o'clock. So we requested maybe the other ones also that were living far away to go, and then we promised them that we're going to record the videos and then show it back to them at a later stage. My team have been introduced. I'm the founder of Arrows Technologies. I have a team here, like our program leader said. They are program coordinators, but for the purpose of this activity, we separated into teams. But the plan of this team is to select, they had to select a program. So the first program, if maybe one of my team can put it up. The first team is Global Disaster Monitoring, that's team 1. There we go. I'm just going to ask us Untlamezi. She's the education assistant, but also a program coordinator for Bethany Village, which we're working with students there that are left behind, and she's just going to introduce what each team focuses on. If we can maybe focus, let's start with team one, please.
Hello everyone, I am Ontlametse from Lerotodi High School in Bethany. The first team, which is team one, was focusing on local disaster monitoring. And this team used information from Arrow's GDM user interface, Google Timelapse, Zoom Earth, Land Viewer, the South African Weather Service, and Sansa Space and Solar Weather.
They basically focus on monitoring floods. They focus on monitoring earthquakes. They also focus on monitoring the tsunamis using the satellite images and live satellite data. And these are some of the programs that we're using, like Zoom Earth. Most of them are available for everyone to access.
While we're still waiting for team one, I'm just going to give a brief description of what team two is focusing on.
Okay.
The second team's main focus was local farm and crop monitoring. Their team used information and data from EOS Crop Monitor user interface. They used mile site sensors and cloud user interface, Zoom Earth, and the South African Weather Service.
Okay, thank you.
Thank you.
Most of the children would use a crop monitor because it can also monitor other things as well. Some of the things that we've been able to use, on the screen at the moment, we also using crop monitor to monitor a farm, a local small farm, and then we also use it to monitor a lake near this village, and then we also use it to monitor a crop, and then we've been able to use the same technology to discover underground water in the local area. And then also we've been able to use that for the same crop monitor. We've been able to use it to monitor a local farming and local mining company. The environment, we can also use that for the environment and stuff like that. So if I can maybe go to the mine and see if we can see anything from there. So some of the kids that are focusing on, I'll just save time, because some of the kids that are focusing on, this is team 3. Team 3 is able to use crop monitor also for natural resources monitoring, and they also use it for water, also like water availability in the community. We also refer to that as local resource monitoring as well. So not only the lake, but they also, the mine, but also the water resources in within the community. But then the ones that are using it for disaster monitoring, what they're looking for, the difference is what they're looking for, even if they're using the same software. They are looking for whether the river is flooding, or we've seen the worst case scenario in KZN recently. We've seen it in Eastern Cape as well. That's when we were having trouble. But we believe that if we have local programs that are run locally by the locals, the goal is to give them the opportunity to be able to monitor their local environment and the disaster in their own communities. Then we are able to maybe report to the weather emergency services and all those kind of stuff. I don't see the kids anymore. I think we lost the kids, unfortunately. I'll just quickly go through Team 2, just to save time. Team 2 uses, our coordinator said, they're using it for farm monitoring and crop threat alerts. So I'll just show you how the threat alerts can be, and then how the kids on Team 2 can use farm crop alerts. So here is a small house or a yard, but there's bananas there. So what we will look at is the task that the children would have on maybe a local farm or on in the local community, where they can use existing, they can use their cameras. So this task was that maybe the child had a task, or the farm or had a task to look at whether the plant was healthy or the crop was healthy. It could be a tree in the local area, whether it was healthy, whether it was watered, those kind of things. Let's see what water the crops. The task was simple here, was just water the crops. And then by taking pictures and loading it on the system, wherever we are able, within the team across the country, we are able to see whether it was whether it's healthy, whether it was watered, but it looks like it was only giving a little bit of water there. And that is a banana tree in one of our local mission control centers in Bethany Village. And then one of the, because we don't have the kids online, so I guess we could just jump between the teams. Is that okay? Yeah. Can we introduce a team? Okay. Can we get a team? We don't have team 6 online, right? It's okay. So I'll just introduce also Team 5. We'll just jump to Team 5 quickly, which is a partnership between our collaboration with our team, Arrows Technologies. Mission Control also works with Abiri Technologies, which is a collaboration we forged by meeting here in the last event. So,
If you can just stop sharing so that I can just show what Team 5 is doing.
Thank you.
Thank you.
And they're dealing with, the team is Team 5. They deal with animal tracking, and they also use that technology for asset tracking.
Yes, thank you so much. So, as my colleague has already alluded, so we are from Abiri Innovations. We deal with livestock tracking and monitoring. So, Team 5, the learners were supposed to focus on the importance of livestock tracking and the importance of it to the communities. So, through the livestock tracking and monitoring, they said we can help the community by deterring and fighting livestock theft while promoting better grazing patterns and providing early disease detection insights. So just to take you through here what is really happening, you're seeing a real-time tracking of an animal. This animal belongs to a client called Ushelo, and you can actually see here the time or the date, the mileage that the animal has moved. You can see the direction is northeast. You can see the speed at which the animal is moving. So you can see it moved from here, and then it went, the green line shows the movement, the actual movement. It went through the water, here's the river, where the animal drank, and then it had to move all the way, and currently it's here. So I'm gonna show you also here, quickly, if the screen can be shared, yes. just to play back how the animal had moved so that you can see it. Just quickly, while it's still loading, just bear with me. Let me just do slow so that you can actually see how it actually is moving.
Okay.
Let me put on the satellite view. So you can actually see the actual movement. So if you look at this, I put it on the slow. So it will show you that it had moved the P, they actually present where it actually had stopped. So you see it's moving here, it's actually the movement where it had made, the livestock made. So actually, if you can focus on this, you see where it went. So we're tracking actually where it had moved. So you can actually be able to follow the pattern and the movement and the history of the movement of your livestock. Thank you so much from Team 5.
Thank you. Thank you. Team 1 and 2, are we ready to show what the Team 4 was showing? Okay. Can we move to Team 7, if that's okay? Team 7, the kids were the program was connecting the community, was it? Connectivity and information, sharing with the public. So on this Team 7 can be used by government, local schools, they can be used by local public and all those. So Team 2, can you, let me introduce our Team 2 coordinator, and then maybe you introduce yourself as well. Team 7, sorry.
Sorry. Afternoon, ladies and gentlemen. Basimane Moropa here. It's an honor and a privilege for us to grace ourselves as the youth and bring into the space conference a little bit of new and fresh ideas. So Team 7 is basically communication and public connectivity program. So what it does, it focuses on public information, sharing, awareness, and public alerts through our cell phones, computers, Wi-Fi connected TV boxes that are supplied by Aeros Technologies. We use these satellite dishes that are pretty much the same as the ones that are used by DSTV, but they are a bit bigger. Also used on ATMs for larger community Wi-Fi and public information sharing. We make use of A6 Next server as a server that can be used for a household and gives 1 terabyte free storage for the whole family with a satellite Wi-Fi. The importance for this is for us as the public and the community to share information and increase public awareness, knowledge, and opportunities. Already we have hotspots and smart poles that are connected lively in Lotus Gardens outside Pretoria City, Gauteng, Polile Village, and in the Eastern Cape. So as in Botswana and Proclamation Hill, where they are also used to connect community security cameras. Thank you very much. That is just a brief information, ladies and gentlemen.
Okay, thank you. By the way, the coordinators were not supposed to be present in this. The children were supposed to be present in this and demonstrating to us how they're using it live. But unfortunately, we lost them. But I think for now, I'll hand over back to the program directors. We didn't cover everything, but if you want to see or maybe learn more of what we do in the communities or want to invite us in the local community or want us to work with the local community, please come to our stand on Aeros Technologies just next to Sansa there and Abiri, and then we'll give more information, share more information. Thank you.
Thank you so much. Ladies and gentlemen, I would like to apologize on behalf of the coordinators because of time restraints. The youth couldn't adequately, present their presentation. It's quite interesting, and we were looking so forward to seeing what they are up to. And I'm hoping that tomorrow they will be around so that we can try and see if we can squeeze in within the program so that they can showcase what they have. So, Mr. David, hopefully tomorrow, we're going to try and organize, and we sincerely, sincerely apologize to your team. Please forgive us. Ladies and gentlemen, this concludes the session for today here in the auditorium. I would like us now to please move over to the exhibition center for the network session, where Major General Matebula is waiting for us. And enjoy the networking session. Thank you.